Hello everyone, welcome back to another video of our multi-threading in Java series. So today we will be building a pathway to understand a very important topic in Java concurrency, which is the executor service. Okay, so to reach executor service, we will first understand and build our own custom thread pool. We will understand what a thread pool is and how can we build our own thread pool, right? So that will set up the base for the executor service. Post that, we will have a small session about how interrupts works in Java, right? And after that, we will then probably jump into callables and futures, right? And after all these topics, finally, we will dive into executor service and you will see how simple it becomes to understand that. So without wasting any time, let's start with an analogy and build the foundation for building our custom thread pool. So imagine you run a restaurant with hundreds of tables, and every time a customer comes in and places an order, you hire a brand new chef just for that order. This sounds crazy, right? So a order comes, you hire a chef and you give that chef to create that particular order. Then second order comes, second chef, third order, third chef, and so on for 100 order, 100 chefs, right? So instead of this, what should you do? You should probably hire fixed number of chefs, like 10 chefs. So for the sake of this example, our example, let's suppose we have hired 3 chefs, right? So we are transforming whatever we had on the left hand side to whatever we see on the right hand side, right? So what we'll do, we will maintain an order queue, and we have hired 3 chefs, right? So whenever a customer places an order, just put them in this order queue, and the chefs can pick the order from the queue one by one as they get free, right? So initially, suppose chef 1 is free, so chef 1 takes order, the first order, chef 2 takes second order, and chef 3 takes third order, right? And post that, order 4, order 5, and n number of orders are queued in this particular order queue. As soon as chef 1 finishes order 1, it goes ahead and picks another order from the order queue, which is order number 4, right? Now instead of chef 2, suppose chef 3 finishes the order first. So if chef 3 finishes preparing order 3, then chef 3 will come here and pick up the next order. Post that, if chef 2 gets free, chef 2 can come and pick the next order from this particular queue, right? So this is how it goes. We have created a queue and we have created a fixed number of chefs. This is very important. So by doing this, what have we achieved? So we have achieved a lot of advantages. So what are the advantages? We have reduced the expenses of hiring new chefs for every order, right? Because now the number of chefs are limited only to 3. We have also done efficient resource management by hiring fixed number of chefs and creating an order queue, right? And overall, by these two, we get better performance for our restaurant, right? We get our orders prepared using less amount of money. It is less expensive, right? Instead of hiring 100 chefs, we have ordered only 3 chefs and maintained a nice queue, right? So similar is the case for Java threads, right? So in Java threads, consider this example. Suppose we got a lot number of tasks, or you can say unlimited number of tasks to process one by one, and you create a new thread for each and every task. Then it will be an overhead, right? Why it will be an overhead? For every task, creating a thread and then destroying that particular thread, that requires a lot of memory and CPU processing. So that is very expensive for our program, for our CPU in general, right? So if there are too many threads, also there will be a lot of context switching between them, right? So there are 2 major disadvantages. First of all, lots of memory, lots of CPU processing, right? Creating and destroying threads repeatedly, plus context switching overhead for threads, right? So instead of doing that, we will do the same thing that we did using chefs and queues. So we have maintained a queue for now. Forget about this blocking queue, whatever it is written here, right? So imagine we have a queue, and that queue has a lot number of tasks that comes one by one, right? So to avoid this, we would make a system which is similar to the restaurant. So we will have limited number of worker threads, right? Worker threads, sorry, this is analogous to the chefs, the limited number of chefs. So these worker threads will be responsible for doing n number of tasks, right? So this worker threads, as soon as they get free, they pick up task from this task queue which we have created, right? So similar to the order queue, we have task queue in which task will be pushed one by one, and as soon as our workers get free, they pick one by one task from them, right? Now in Java, to achieve this, and also one more thing what we want here, we want a single order or a single task should not be processed by two threads, right? So to instead of using wait, notify and all those to block the access of a single task for two threads, what we do, we just create a blocking queue. We have a class called blocking queue in Java. We create a queue using that, right? So this is what this blocking queue is, correct? So I'll go ahead and erase this. So this is why we have used blocking queue in terms of Java, right? So here also, what are the benefits that we'll get? So we'll get benefits of reusing the worker threads, right? Our worker threads will be reused. Second, we are managing concurrency better, correct? We have created a queue. All the threads are taking task one by one. It is happening in parallel as well, but with a structured approach, right? And most importantly, there is no overhead of creating and destroying threads again and again, right? So this complete system that we have made, inspired by a restaurant and chefs, this complete system in Java is known as Java thread pool, and this thread pool is the foundation structure of executor service that we'll study in later lectures, right? So what will be the formal definition of thread pool, right? So this is a formal definition of thread pool. A thread pool is a design pattern in multithreading where a fixed or dynamically managed number of threads execute tasks from a shared queue, right? Where fixed number of threads execute tasks from a shared queue, this blocking queue, right? And what else it does? This helps in efficient resource management, better performance, and avoiding the overhead of repeatedly creating and destroying threads, right? So if we compare this Java example to our restaurant example, so what will be the analogy? Analogy will be chefs correspond to the worker threads, limited chefs, limited number of worker threads that we have created. Our order queue is corresponding to the task queue that we have created using blocking queue, and the complete restaurant system is analogous to a thread pool in Java, right? So I hope you are clear with what a thread pool is. Now let's build our custom thread pool by going into our IDE and actually coding it, right? So let's directly jump into our IDE and create our custom thread pool. Okay, so what is the first class that we will need? So we will need our task class, right? So the order queue which we want to fill, in that we will fill out tasks, right? So let's go ahead and create our first class, which is named as task. Now we want this task to be executed by threads, right? So this, whatever task you need to perform, you need to write inside the run method so that it can be run by the thread. So let's go ahead and implement the runnable interface. Implements runnable, right? And post that, let's go ahead and implement the run method, correct? So what will this task have? This task will have its own ID, right? Private int ID, and this, let's initialize this using our constructor. This is done, correct? Post that. Okay, so in our run method, what task I will perform? I'll just write system.out.println task ID, correct? So task, whatever ID is executed by whatever thread name that we have, right? So it will print this task is executed by thread name, whatever threads we will create later, right? So this is our orders that will be kept in the queues, right? So this we have created for that. Now to execute these tasks, we need workers, right? Or to execute these orders, we will need chefs. So let's go ahead and create our chefs/workers, right? So let's create a new class named worker, right? now we want this worker to be executed as a thread, right? So we'll go ahead and extend thread, right? And after this we'll go ahead and override the run method, right? Override and run method. Now before that, what all access do our chefs has? So chef will have access to the order queue, right? The customer order queue, chef will have access to that. Similarly, our workers will have access to what? The task queue that will be there, right? So let's go ahead and create that queue. So blocking queue, and we'll have task and task queue, right? So our workers will have access to our task queue, correct? And they will also have their own name, right? Every worker will have some name. So private string name, correct? Now in our run method, what we'll write? Or before that, let's go ahead and create constructor. And I think even this is not needed because this will already be handled by this super, right? Now what else? We have made our constructor, we have made a blocking queue, a task queue. Now let's go ahead and execute these tasks, right? So to execute this task, what we will do? We'll iterate for infinite number of times. We'll go ahead and fetch task from the task queue and execute that, right? So let us fetch task from the task queue. Task equals to task queue dot take. So take is the method that we have to use, and after that we'll do task dot run, right? And if we catch any interrupted exception, what we'll do? Let's go ahead and set the interrupt flag and break from here, correct? So what exactly we are doing here, you don't need to understand. I'll explain it in later videos when we'll learn about interrupts, but moreover we are catching the exception here, right? Main thing is this: we are fetching the task from the task queue and we are executing it, correct? So this is a simple worker class. We have created task class. Now let's go ahead and create our thread pool class, right? Thread pool class combines both the task and workers, or you can say we are creating a complete restaurant. So this is analogous to restaurant, right? So let's keep this my thread pool, correct? This is my thread pool. And what will our thread pool have? Our thread pool will have, first of all, total number of chefs or total number of workers that we want in our restaurant. So private final int, first we'll take pool size, right? Post this pool size, what we'll have? We'll have access to the workers. So let's create workers. And after creating list of workers, what else access do our restaurant have? Restaurant will have access to the task queue as well, right? That is a complete restaurant, complete thread pool. So let's go ahead and create our task queue. Private blocking queue task queue, correct? Now what else? Now let's go ahead and write our constructor, right? So in our constructor we will take only one input, which is pool size, the number of workers that we want, and then we'll initialize this dot pool size equals to pool size. Now the number of workers that we have received in our constructor, we will create that many number of workers, correct? So we'll do this dot workers equals new pool size. We have created those number of workers, and post that let's initialize our task queue, right? So our task queue will be task queue equals to new linked blocking queue. So basically linked blocking queue, you can also use array blocking queue, but I have used linked blocking queue because it is unbounded and it can take unlimited number of tasks inside it, right? And then post this, we'll go ahead and initialize each of these workers, right? We have created the pool for the workers. Now let's go ahead and initialize our workers or initialize our chefs, correct? So for int I equals to 0, I less than pool size, I plus plus, what we'll do workers I equals to new worker I and worker I dot start. Is right. So why is this giving error? If we first we have name and then wait, this name one should not be there here, right? First we have name and task queue, right? So we have given worker I or worker 0, worker 1, worker 2, and we have provided all the workers access to the task queue, right? Apart from that, what else our restaurant has? Restaurant should have. Our restaurant or our thread pool should have a method by which we can submit the task to the task queue, right? So let's go ahead and create that particular function. So that function will be named submit, right? And we'll just write here task queue dot offer task, right? So this is our simple submit method, right? Using this we will submit our task to the queue, correct? So we have created worker, our thread pool, our task. Now let's go ahead and create our main class, main, correct? Public static void main, and here what we'll do, so in our main class we'll create a thread pool and then we will insert task inside that particular thread pool, right? So my thread pool equals to new my thread pool, right? And pool size not 10, we'll give 3, right? So we'll initially make only 3 workers, right? Now let's go ahead and create 10 tasks, right? 0 I less than 10 I plus plus, and here what we'll do thread pool dot submit, correct? We have created new task, we have given that task a ID, and we have submitted that particular task into our thread pool, right? Correct. So this is all we want to do. Let's go ahead and execute our main class and see what's the output is. Correct. So see our output. So task 0 is executed by worker 0. Worker 0 was free, then worker 2 was free. Then none of the other workers got chance. Worker 0 was able to pick up the task from the task queue and execute all these tasks till task 9. Then task 4 was executed by worker 2, and then task 2 was executed by worker 1, right? So if I stop this program and rerun this, you will see a different order here, right? Correct. 2 0 2 0 2 2 2 0 2 1 0, right? So most of the tasks were executed by 2 and 0. Worker 1 got only one task, which is task 1, correct? Now what is the one problem that we have? So one problem that we have is our thread pool, after executing 10 tasks, our thread pool is not closing, right? So there is no shutdown in our thread pool. So we have to create a shutdown function as well. But before creating a shutdown method in our thread pool to gracefully close our thread pool, close our machine, first we will understand what interrupts is, how interrupts works in Java multithreading, and post that we will write our shutdown method because it requires some knowledge of interrupts, right? So for now, I hope you are clear with how to create your custom thread pool without a shutdown method, correct? Shutdown method we will create in our next class, right? So if I close this, if I exit this program and again execute it, correct? So you can see a different order, right? So you can play with it, write some more complex task inside our task class, inside this run method if you want to execute some task, and play with this custom thread pool. So you saw how simple it is to create your own custom thread pool. Generally, when we get this question in interviews to create our own custom thread pool, usually the candidate becomes blank. right? So now you know how to create your own. So I hope you are clear with what a thread pool is and how to create your custom thread pool, right? So that's it for this video. Until the next video, stay safe, stay healthy. Bye bye.